In this video, we'll learn why software design matters and we'll talk about fixing poor design with solid principles. Every software system has two values, behavior and design. Behavior is what the software is supposed to do, meaning its functionality. So if the software is an e-commerce web application, then it should allow the users to do online shopping. Design refers to the shape and structure given to the software, how its components are laid out, and how the classes within those components are structured and interact with one another. Now, why is design necessary? Design is necessary so that we can change the behavior of the software when the requirements of our end users change. Let's say we built a piece of software that has all the required behavior but does not have a proper design. Initially, it meets the needs of the end users, but the requirements of our end users may change at any time, and when that happens, we need to change the behavior of our software. And sometimes, these changes may need to be done by developers who are not part of the original development team. Since the software does not have a proper design and there is no defined structure for its components and classes, making those changes will be difficult for the developers. In order to minimize the effort required for making such changes, the software needs to have a proper design. So how do we determine if our code has a proper design? We can evaluate the quality of our code's design by looking at the symptoms of poor design. And these design symptoms are called design smells. First, we have rigidity. Software is rigid when it is difficult to change. So when we change one part of the codebase, we need to go ahead and change other parts of the codebase as well. The next design smell is fragility. Software is fragile if it is easy to break. So a single modification to a program causes it to break in multiple places. Third, we have immobility. Immobility occurs when software is difficult to reuse. Some components within the system may be useful for other systems, but the process of separating these parts from the original system requires a significant amount of effort. Fourth, we have viscosity. Viscosity occurs when it's difficult to do the right thing. As I already mentioned, software has two values, behavior and design. When we make changes to the software, we need to preserve the design. If it's difficult to make changes to the software while preserving the design, then it means that the viscosity of the software is high. The fifth design smell is needless complexity. When there are no other design smells and we apply design principles just because we anticipate changing requirements, then we are over-designing the software. So the design may contain unused elements, leading to unnecessary complexity. Sixth, we have needless repetition. Needless repetition occurs when a piece of code repeats in multiple places, and when changes need to be made, these changes need to be applied to each repeated instance of the code. Finally, we have opacity. Opacity occurs when code is difficult to understand. Initially, the software's opacity will be low, but as time progresses and we add more code, such as more if-else logic, the software's opacity will increase. So we need to make sure that we consistently maintain low opacity. Now, all these design smells occur due to a violation of one or more design principles. So we can apply design principles to address those design smells. Now there's a set of principles that tells us how to structure classes within our application. These principles are referred to as the solid principles of object-oriented design. There are 5 such principles, and the word solid is an acronym. So the names of the principles start with each letter of the word solid. We have the single responsibility principle, open-closed principle, Liskov substitution principle, interface segregation principle, and finally, the dependency inversion principle. For the rest of the course, we'll be discussing these principles and we'll explore them in the following order.